Good afternoon. Today is Friday, September the 11th. Today we completed section 2.4, which is talking about rational root theorem. I'm going to show you a couple of types of problems that you will see in your homework. So I will share the screen here. And show you those two types of problems. The first type of problem, it gives you a set of roots. So we'll go through here and we will look at the root. So you have a function has a root which is -1, has another root at 8, and has a third root at 6 minus I. Remember, when you see something like 6 minus I, that's a complex root. And the thing you need to remember is that complex roots occur in pairs. So if you have 6 minus I, you also have 6 plus I. So you would have 4 roots here. And what we're going to do here is we'll go in now and we'll start writing out the function. So the function, we can say f of x equals, so if we have a root of -1, we have a factor of x plus 1. If we have a root of 8, we have a factor of x minus 8. And then if we have a root of 6 minus I, we have x minus parentheses 6 minus I. So we got to close that twice. And then we also have a root of x minus parentheses 6 plus I. Now, so if you look at this, when we are trying to multiply it out, we have f of x equals, we can multiply the first part out here, so we have x squared, and then we have minus 8x plus x, so that's going to be minus 7x, and then we have minus 8. Now, if you look at these back two, if you get rid of the parentheses there, you have x minus 6 plus I, and you have x minus 6 minus I. And if you'll notice here, I'll show you something. If you look, you have the same, you have x minus 6 here, and you have x minus 6 here. And then you have your I here. Let's do that one like this. And then you have your I here, like that. And you notice it's set up where you have the, if the x minus 6 is your A and the I is your B, you have an A plus B and an A minus B type of configuration. So it's really easy if you remember. So you would have f of x equals your x squared minus 7x minus 8. And then you multiply this by, and you remember what happens if you square a binomial, like you square x minus 6, you get the square of the first, which is x squared. You get minus twice the product, so the product is 6x, so you get a minus 12x, and then you get a minus 12x, and then you get plus the square of the last, which is plus 36, and then you get minus I squared, And remember, I squared is -1, so that's a minus. So your final answer here is going to be, start right here, equals, you have x squared minus 7x minus 8 times x squared minus 12x plus 37. And then you can multiply that out, but normally when we get to this point right here, we've basically gotten to where we need to get to. So the key there is, in that type of problem, if you are given to start with a list of roots, and one of the roots is imaginary, as we saw here with 6 minus I or complex, then you also have a 6 plus I, or the opposite conjugate root as well. Okay, so that's one type of problem. Now, you can pause this and look at this, but I'll go ahead and erase it, and I'll show you the second type of problem that you can run into. And the second type of problem, what you run into is something that has fractions in it. So here's my function. We can do f of x equals, we're going to do x to the 5th, and we can do minus parentheses 5 divided by 6 x to the 4th plus parentheses 2 divided by 3 times x to the 3rd minus parentheses 2 divided by 3 x squared minus 1 divided by 3 x plus 1/6. Now, what you'll notice here, if you remember, if I take and multiply a polynomial function like this by a number in front, then I don't change the roots. All I do is change the amplitude. So in order to get this thing and get rid of these fractions here, what I'm going to do, I'm going to create another function which we'll call g of x. So we say g of x equals 6 times f of x. And what I can do, if I multiply this whole expression by 6, I get rid of all of my fractions. So I would have 6x to the 5th, because 6 times 1 is 6. I would have minus 5x to the 4th, because that takes care of the 6. Then I would have plus, if I multiply 6 times 2/3, I get 4x to the 3rd. And then I get minus 4x squared. And I get minus 2x. And I get plus 1. Now, if you look and you go back to rational root theorem, but the key to remember, if you take this expression right here, I got an extra minus there, but that's okay. If you take this expression here and put it in your calculator, it looks like your roots are, looks like you have a root at 1. It looks like you have a root at 1/2, and then another root at minus 1/2. Now, you know 1 works because if you add your coefficients, you got 6, minus 5 is 1, plus 4 is 5, minus 4 is 1, and then 1 is 2, and minus 2 is 0. So if we come down here and do our synthetic division now, so we're going to go like this. What I want to show you is you can follow through. So we go all the way across like this. So we're going to try 1. I'm going to put a 1 here. And then we put the coefficient, so we got the 6, minus 5, the plus 4, the minus 4, the minus 2, and the plus 1. Okay? And we will do our synthetic division. So we drop the 6 down. So we drop the 6 down. We multiply by the 1, so we get a 6 here. That leaves, if we add, we get 1. 1 times 1 is 1. We add, we get 5. 1 times 5 is 5. We add, we get a 1. 1 times 1 is 1. We get a minus 1. And 1 times minus 1 is minus 1. And we got a 0. Okay? Now, so that tells us that 1 is a root. So we come over here and we continue down. Now remember, do not go back and start over, because if you do, you never get anywhere. So we're going to put a 1/2 here. Okay, and then I'll put the line underneath here as before. So run the line across like this. So now, so once again, we bring the 6 down. Half of 6 is 3. We add 3 and 1, we get 4. Half of 4 is 2. And we get a 7. Half of 7 is 3.5. Let's see. Half of 7 is 3.5. And we do that now. Something, if you notice, something is not going to work out right here, because this thing is not going to give us a 0. So let's go back. So we're going to erase, undo what we did. We can erase this bottom line here. Erase this, this, and this, and this. And let's put the minus out in front here. Okay. And we'll come down here. All right. So we bring the 6 down. Okay. Half of 6 is minus 3. We get a minus 2. Half of minus 2 is 1. We get a plus. We get a 6. Half of 6 is minus 3. We get a minus 2. And half of minus 2 is 1. So we get a 0 there, right? Now, let's try it. Let's go down. So that tells us that minus 1/2 works. So let's go down and put in the 1/2 now and see what happens here. No, I shouldn't do that here. So I can go down and put in my line like this. Okay, now, So I can drop down my 6. Half of 6 is 3. I get a 1. And see, this is not going to, once again, this is not going to work. Let's see, if I get, say when you're doing this, it's you try something and see what you get. And if it doesn't work, let's see, let's do this. Let's try instead of 1/2, let's try a 1/3. So we're going to go back one more, right? Okay, so let's try a 1/3, right? So now if I come across, and as you can see, sometimes this gets to be a trial and error type approach. So you bring the 6 down. Bring the 6 down. Now, 1/3 of 6 is 2. So you got a 0. So 1/3 times 0 is 0. You get a 6. And then you get 1/3 times 6 is 2 again. And see, then you get your 0, okay? So now what we found, so up here, then we know that the 1/2 becomes a 1/3, okay? And now what you notice you've got, since you started with a 5th degree polynomial, you now have a 2nd degree, which means you have 6x squared, or you can factor out the 6. So you get x squared plus 1 with 6 multiplied by it. And you notice x squared plus 1, if you try to factor it, you get imaginary answers. So you know that in this particular case, this polynomial has 3 real roots and 2 imaginary roots, but it has 5 total. But like I say, the thing I wanted to show you here, the key to this problem is when you have fractions like this to start with, you can multiply the polynomial by a number out front like we did here with 6, and you don't change the roots, you change the amplitude or how tall it is, but that does not affect the roots. So you can do something like that to make the polynomial function a little bit more easy to work with. So I'll stop sharing here now. If you have any questions, as always, send me an email and I'll get back to you with it. So I hope you have a good weekend. And as always, let me know if you have questions or problems.